Toyota just went ahead and made one of the boldest moves ever, as their all-new way of thinking completely contrasts the entire automotive industry's idea of the future. Instead of going towards an all-electric future, Toyota decided to breathe new life into the world of internal combustion engines. And according to their CEO, their all-new engine will disrupt the entire car industry and its current flow. However, this decision did not come out of nowhere, as Toyota's insistence on keeping their internal combustion engine going has been one of their driving factors for quite some time. These engines and their notorious reliability are what have kept Toyota at the top of its competition, and it is only logical for them to keep exploring and modernizing them so that they can maintain that gap, and they truly outdid themselves with the final product. We are talking about a revolution that is greater than the hybrid revolution, pioneered once again by Toyota and its Prius. You can only imagine the sheer and unfathomable importance that this technology harnesses. So, with that in mind, let us answer the question that you are currently asking yourselves, and that is, what is this all-new technology? The technology we are so absorbed and mesmerized by is Toyota's all-new hydrogen technology. And no, we are not talking about hydrogen electric vehicles such as the Toyota Mirai. Oh no. What Toyota is doing now is introducing their all-new hydrogen combustion engine technology. You see, FCEVs such as the Mirai have a bit of a performance issue, and by that, we mean that they were severely underpowered, extremely overweight, and very mediocre in terms of daily usability. Even 10 years after their original inception, they are still way too impractical to be useful. But what we cannot deny is the ecological component that comes with using hydrogen, seeing how it is the most abundant element in the world. And since it is also completely eco-friendly, it is understandable why Toyota wanted and still wants to develop cars that use it. This is especially interesting now, at a time when lithium-ion batteries tend to stir up quite a lot of controversy regarding how eco-friendly they truly are, given that lithium mining poisons both the soil and the water surrounding the mine. Furthermore, even with the continuous development of lithium-ion batteries, recharging them as well as their range simply leaves a lot to be desired. Now, combining the potency of regular internal combustion engines with the ecological benefits of hydrogen would effectively remove all issues of both technologies altogether. BMW already explored this technology in the late 90s and early 2000s, and it showed a lot of potential even back then. BMW's hydrogen-powered E38 and E65 7Q V12 engines were proven to be quite reliable, and had plenty of power without being any less economical than their gasoline counterparts. However, hydrogen infrastructure back in the day was non-existent, which is why neither of the two moved out of the prototype phase. But thanks to Toyota's efforts with the Mirai, the network has grown quite a bit since then. As a result, Toyota, unlike BMW, now has actual backing to start making their own hydrogen combustion engine, which is exactly what the company is doing. With all of this in mind, it is time for us to peek into the specifics of the hydrogen combustion engine and explain what its similarities are to regular internal combustion engines. The biggest similarity between the two technologies is, obviously, the fact that they both rely on internal combustion. Also, gasoline engines tend to be exceptionally good hosts for modifications that allow an overhaul and conversion to hydrogen. Most hydrogen power plants are designed this way, especially Toyota's. There are two engines that Toyota currently has in their portfolio, both of which are designed for different purposes. The more popular of the two is the 1.6-liter turbocharged 3-cylinder, yes, the same unit that is found in the GR Yaris and GR Corolla. The engines are so alike that despite the change of propellant, the hydrogen 1.6-liter sounds just as growly as its gasoline counterpart. Music. The other power plant is Toyota's 5-liter V8, derived from the same unit used in the Lexus RCF. This engine, unlike the 1.6-liter, which is planned to be used in sportier, smaller cars, is designed as a workhorse engine. Toyota's plan is to use this powerhouse of a unit in its pickup trucks, large SUVs, and even some large sedans and coupes. And do you want to hear the best part about all this? The fact that neither of these engines lost much power after being converted to hydrogen? Sure, there was a drop in output, however the difference is negligible, to say the least. But for these performance figures to be achieved without sacrificing Toyota's trademark reliability, several crucial changes needed to be made. There have been quite a few modifications made to the venerable 1.6-liter and 5-liter engines to make them function reliably using hydrogen. First, and by far the most important change, is the fuel system. Hydrogen is a gas, and it has to be pressurized and cooled to the point of liquefaction. This means that the fuel system needed to be changed to something that tolerates extreme pressures better than the regular system, which is designed for a liquid fuel. These changes include most prominently a changed fuel pump and injectors, as well as fuel tanks that are structurally different from regular fuel tanks. They are the same as the ones used in the Toyota Mirai, meaning that they are quite massive, like LPG tanks. The ignition system has also been swapped out for a different solution, using different spark plugs that ignite hydrogen more efficiently compared to the traditional spark ignition system. Additionally, the ECU also needed replacing so that it could optimize performance and fuel efficiency, allowing the engine to be much better utilized and significantly increasing its longevity. However, the biggest changes of them all are the structural ones. You see, despite the two engines being based on the same unit, there have been several truly structural changes, such as a swap to sturdier materials for the valves, the head and head gaskets, as well as the camshafts and the crankshaft. These modifications were made to mitigate the reactivity that hydrogen is well known for and to increase the expected lifespan of the engine. As a result of these extensive modifications, both the 1.6-liter and the 5-liter hydrogen engines retained most of the performance figures of their gasoline-powered twins, while also being just as fuel efficient. The 1.6-liter has been tested in a myriad of different vehicles, including the Toyota GR Corolla and Corolla Cross, and most prominently, the Toyota GR Yaris. The 5-liter is planned to be tested in the Land Cruiser as well as the Toyota Tundra and Sequoia further down the line. However, with great power comes great responsibility, and with great popularity comes a great number of problems, which is why we must ask, are there any issues with using this technology? Yes, a lot of issues have been brought to light. The biggest and by far the most prominent one is the acquisition of hydrogen. Sure, it is the most plentiful element in the universe, however, it is seldom found on its own. Hydrogen is mostly a part of a compound, which means that it requires processing before it is ready to be used. While extracting it from water might sound simple, the truth is far more complicated. This requires electrolysis, which is a convoluted and expensive process, not to mention that it cannot be performed everywhere, as it requires specific conditions to be successful. As a result, getting a hold of hydrogen is, at least for now, quite a costly venture that is hardly profitable. Driving a hydrogen car is currently over 14 times more expensive than driving an EV, which is not something you want to hear when competing against EVs. Not to mention that the electrolysis process requires electricity, defeating the purpose of replacing EVs with something more eco-friendly. Furthermore, even if you were to extract hydrogen cheaply by some miracle, another problem arises: storing it. Hydrogen is a highly reactive gas, and hydrogen storage is a delicate ordeal that requires perfect conditions for safety. This issue is especially concerning when storing hydrogen in a car, as it requires specialized armored tanks. Since hydrogen is a highly corrosive gas that can easily escape due to its molecular structure, hydrogen tanks need to be almost bulletproof, which means that they are much heavier than regular tanks and even batteries in some cases. This in turn lowers the range and the performance figures of vehicles that use hydrogen, while also making the interior space much more cramped due to the size of the tank. Hydrogen fuel is emerging as a promising alternative energy source, offering the potential to significantly reduce our carbon footprint. With its high energy density and clean combustion, hydrogen could play a crucial role in the future of sustainable transportation and energy systems. However, there are several challenges that need to be addressed before it can become a mainstream energy solution. Plus, despite the infrastructure being noticeably better than it used to be in the 2000s, it is still far from being reliable and daily use friendly. There are only a handful of hydrogen charging points worldwide, making the fuel quite unreliable for day-to-day use. Finally, as mentioned, hydrogen is a highly reactive gas. This means that if it escapes somehow, it could spontaneously combust, which might lead to fatal outcomes, and nobody wants that. But despite the situation for hydrogen seeming grim, Toyota is adamant that the company will find solutions to these issues in no time. How will Toyota mitigate these problems? Toyota has had no rest ever since they revealed their first hydrogen combustion engine, and they have been working hard on finding solutions for the mentioned problems. First is the acquisition of hydrogen. Toyota is counting on the expansion of hydrogen not just in the car industry, but in all industrial and commercial spheres. This might sound optimistic, However, there has been a rapid increase in the popularity of hydrogen in every way possible. Shipbuilders are very vocal about switching to hydrogen combustion engines. Modern cities are slowly but surely starting to rely more on hydrogen farms, as well as industries starting to utilize it as a proper power source. Also, with the increased reliance on hydrogen, the price of the gas will lower significantly over time. Sure, we are a long way from truly affordable hydrogen, but with the increase in use, we can expect an exponential decrease in price. Sure, you should not expect hydrogen to be cheaper than electricity, however, it will most certainly be much cheaper than gasoline. Furthermore, when it comes to fuel economy, Toyota is doing its best to lower consumption as much as possible, which would bring running costs down a notch. What about the tanks? If well maintained, they should not give you a headache. Just be sure to inspect them regularly. Oh, and let us not forget the price. Unlike EVs, which require extreme processing to become daily usable, hydrogen combustion engines are just a regular old lump of metal that is fast and cheap to produce, making it ideal for mass production. However, even with all these developments, there is another technology that Toyota is developing as a basis for hydrogen cars, Toyota's new ammonia engine. Toyota has recently started exploring the possibility of using hydrogen and storing it safely by simply not dividing it from the compound that it is a part of. Their long and extensive research has led them to the idea of using ammonia as a propellant. Despite water being the most obvious choice for a hydrogen container, extracting hydrogen from it is quite a nightmare, at least currently. On the other hand, storing hydrogen is also exceptionally problematic, as already mentioned. This is exactly where ammonia comes in. You see, ammonia, which consists of nitrogen and hydrogen, serves as the best middle ground for hydrogen's further development. This is because ammonia, unlike water, can combust, making it an actually viable fuel. Furthermore, since ammonia is combustible and since hydrogen is one of the two parts of its composition, dividing hydrogen is not required. This therefore eliminates the need for one of the most complex and cost-ineffective parts of utilizing hydrogen as a propellant. Not to mention that by not dividing hydrogen, you will also be eliminating the need to store it too. This means that another expensive part of the hydrogen future will be cut out of the equation entirely. Oh, and you can also say goodbye to heavy large fuel tanks too, as ammonia is incomparably less problematic to store than hydrogen. Furthermore, ammonia is also extremely plentiful, seeing as it is the most abundant alkaline gas in the atmosphere. This means that it is also exceptionally affordable for purchase, exceeding gasoline in terms of affordability, let alone hydrogen. Plus, ammonia is much more stable than hydrogen, which in turn results in it being noticeably safer too. Unlike hydrogen, which is very explosive, the only thing you should worry about with ammonia is not inhaling it. The storing process is otherwise identical to storing liquid petroleum gas, for example. Toyota is so on board with this idea that the company paired up with the Chinese automotive giant GAC to make their own ammonia-powered engine. And they recently did just that. So, when it comes to performance and future prospects, ammonia seems to hold quite a bit of promise. It's fascinating to see how various industries are exploring its potential to revolutionize energy storage and usage. The future surely looks bright for ammonia as a sustainable energy source. Their 2-liter inline-4 runs on liquid ammonia, and after extensive testing, the engine proved to be 10 times more eco-friendly than its gasoline counterpart. Sure, this is not truly zero emission. However, neither is going fully electric, as both making batteries and producing electricity for them is extremely polluting. Plus, ammonia engines are technically hydrogen engines with only a few differences, most of which can be summed up in the fuel injection system. As a result, they will also allow for parallel development of hydrogen as a sole propellant, making it a very future-proof and forward-thinking technology. Is hydrogen the future? Speaking of the future, it is time for us to ask the most important question. Is hydrogen the future? Well, it is still too early to say. However, we do believe that hydrogen is shaping up to be the fuel of the future. You see, despite its current hardships, it is simply undeniable that hydrogen currently has the most potential out of all other means of powering vehicles. Despite its issues, hydrogen remains the only way of powering vehicles without any emissions. Not to mention that with the development of the infrastructure and technology that surrounds it, hydrogen can achieve an incredibly low, borderline, non-existent price tag. Additionally, the EV industry has been getting quite a lot of backlash in the past few years, as lithium-ion batteries continue to be insufficient for real-world use while also being extremely polluting and expensive to produce. As a result, even 10 years after they became popular, EVs are still a niche and luxury product with exorbitant price tags and limited use, exactly what hydrogen sets out to fix. As we look to the future, it's clear that hydrogen holds immense potential. With continuous advancements in technology and infrastructure, hydrogen could very well be the key to a sustainable, emission-free world. The journey might be long, but the destination promises a cleaner and more efficient future for all. Granted, we do not expect hydrogen to become popular imminently. However, Toyota's insistence on developing it and the currently rising prominence of synthetic fuels, as well as the drop in popularity of electric vehicles, suggest that there is quite a lot of reason to believe that hydrogen is far from obsolete. Not to mention that the most ambitious projects in the world, such as Saudi Arabia's The Line, also account for hydrogen's potential and expect it to be the main power source for the entire city. Plus, with the development of other hydrogen-based technologies that are more user-friendly currently, such as ammonia engines, hydrogen will also passively increase in popularity, and its development will be fueled indirectly. Overall, despite the myriad of problems that it is facing now, we expect that hydrogen will, in the next decade or two, rise to become one of the driving forces for humanity in general.